we want to use the definition of the derivative to compute the derivative for the function f of x equals 1 over x, the reciprocal function. So the first step is to figure out f of x plus h. F of x plus h. Well, the first step is really to write down the definition of the derivative, the limit of the difference quotient. The difference quotient is a slope. We're doing a limit of slopes, and that's going to give us a formula for the slope of the curve, y equals 1 over x. So f of x plus h, we just put x plus h in for x, and the parentheses are unnecessary here because the division bar here, the fraction bar, acts as a grouping symbol. So our limit becomes limit h to 0, 1 over x plus h minus 1 over x all over h. I want to do the division first. Division a divided by b is the same as a times 1 over b. The operation of division is multiplication by the reciprocal. So dividing by h, we are dividing by h, so that's the same as multiplying by 1 over h. So let's look at it that way. 1 over h times the subtraction of the fractions. This is the division by h, multiplied by 1 over h. So now we need to get this h to cancel. We will subtract the fractions. The common denominator is x times x plus h, the product of the two denominators. So for the first fraction, we will multiply by x over x. And for the second fraction, we will multiply by x plus h over x plus h. So now they have the same denominator. But we haven't changed the fractions. The first fraction, you could cancel the x's and get back to this. The second fraction, you could cancel the x plus h's and get back to that. So we're just rewriting the fractions in an equivalent form so that they have the same denominator. And now we can subtract the fractions. We write down the common denominator and we subtract the numerators. It's x minus the quantity x plus h. So this x plus h now, following the minus sign, needs to go in parentheses because the minus distributes. So let's look at that. X minus x plus h is x minus h, distributing the minus. So x minus x is 0. 0 minus h is negative h. So this numerator is negative h. Negative h over the common denominator. And now we can cancel h's. We're left with a negative 1. Let's write that here. Scribble out that minus. We have a negative 1 on the top. So let's write the whole thing again. Just for clarity, we have negative 1 on the top. We have x times x plus h on the bottom. And now that we've canceled the h that was originally on the bottom, we can plug in 0 for any remaining h's, and we get negative 1 over x times x plus 0, which is x times x, and x times x is x squared. So we have our answer. The derivative of 1 over x is negative 1 over x squared. So there's our derivative. Let's take a look at the curve. Y equals 1 over x. It's a hyperbola. And it has a vertical asymptote at x equals 0. It has horizontal asymptote at y equals 0 on both ends. And let's just take a random point on the curve. Let's let x be, I don't know, how about 3? If x is 3, So this curve is y equals 1 over x. So x is 3, the y coordinate is 1 over 3. So the point 3 comma 1 over 3 is on the curve. We have a tangent line, and we want to know the slope of the tangent line. And the derivative tells us the slope of a curve. So we're going to take the x coordinate 3 and plug it into the derivative. So here's our derivative. We're going to put 3 in for x, and we get negative 1 over 3 squared is 9. So the slope of this line is negative 1/9. It's clearly negative from the picture. It's going downhill from left to right, and it doesn't look particularly steep. So negative 1/9 makes sense.